Good morning student. Now I am going to discuss about a new chapter, that is basic concept of organic chemistry. At first I want to know about what is organic chemistry. The study of carbon compound. The study of carbon compound where carbon is covalently bonded to another carbon, hydrogen, nitrogen, oxygen, halogen and sulfur is called organic chemistry. What is the meaning of organic compound? There are generally two types of compound. One is your organic compound, another is your inorganic compound. Organic compounds are generally obtained from living sources like plants and animals. What are the characteristics of organic compounds? Generally, the organic compounds are large and complex. Large means they have generally high molecular mass and their structure is in complex form. Organic compounds are generally non-ionic in nature because organic compounds are generally made by the help of covalent compounds. Organic compound involves cleavage and formation of covalent bond. Organic compound undergoes very slow and reversible reaction. Organic compounds are generally non-polar in nature, so organic compounds are generally soluble in organic solvent like alcohol, ether, etc. Organic compound generally contain functional group. Organic compound having generally low melting point and boiling point. Organic compound are generally bad conductor of heat and electricity. Organic compounds are classified into different homologous series. These are the characteristics of organic compound. Look at that, there are some examples which are not included in the organic compound, just like carbon monoxide, carbon dioxide, carbonate like your calcium carbonate, sodium carbonate, sodium bicarbonate, sodium thiocyanide, potassium cyanide, carbon disulfide, calcium carbide, etc. are the inorganic compound. Example, look at that, your carbon and oxygen are present but they are not said to be organic compound, because these compounds, no doubt they have carbon and oxygen and also they have another element like your hydrogen, and some compounds also having nitrogen, and some compound also having sulfur. They have also covalent bond, but they do not obey such type of conditions. So this type of compounds does not undergo in the list of organic compound. These are the examples of inorganic compounds. There are different types of application of organic compounds like your food, energy, cloth, medicine, household goods, transportation, industry, luxurious, etc. There are different types of application of organic compounds. Next, I want to explain about the Tetra covalency of carbon. The characteristics property of carbon atom by virtue of which it forms 4 covalent bond is known as Tetra covalency of carbon. That means whether the carbon atom forms single bond or double bond or triple bond, but it is bound to maintain the Tetra covalency. For example, look at that. In this case, carbon shows Tetra covalency. There are 4 covalent bonds are present. 1, 2, 3, 4. Like that, you can also think about this is another types of structure. Look at that. In this case, carbon also maintain Tetra covalency. 1, 2, 3, 4. There are 4 covalent bonds are present in this structure. Look at that. In this case also this carbon atom maintain Tetra covalency. Also this carbon atom maintain Tetra covalency. Look at that. 1, 2, 3, 4. That means this carbon maintain Tetra covalency. Look at that. Here 1, 2, 3, 4. That means this carbon atom also maintain Tetra covalency. Similarly, the element present in the organic compound also maintain a fixed covalency. For example, nitrogen maintain tricovalency. Similarly, oxygen maintains dicovalency. Hydrogen maintain monocovalency. Halogen elements maintain monocovalency. Remember these points by which we can able to form different types of organic compounds. But remember, when I will draw the structure of organic compounds, it is bound to maintain such type of covalency, otherwise the structure of the compound will be wrong. By the help of these points, we can able to draw different types of structure of organic compounds. For example, look at that. This is an organic compound. Here, carbon maintain Tetra covalency, hydrogen maintain monocovalency. Similarly, take another example. H bond C, triple bond C, bond H. Here also hydrogen maintain monovalency. Here carbon maintain Tetra covalency. Here carbon maintain Tetra covalency. Here hydrogen maintain monocovalency. Remember an important point, you cannot write the structure of organic compound like this, because here hydrogen maintain monocovalency, but here carbon do not maintain the Tetra covalency. Here carbon maintain the pentacovalency, which is not possible. Look at that. Here 1, 2, 3, 4, 5. That means here carbon maintain pentacovalency, which is not possible. But in this case, carbon maintain Tetra covalency 1, 2, 3, 4. So carbon maintain Tetra covalency. Hydrogen also maintain monocovalency, but carbon do not maintain the Tetra covalency. So this type of compound is not possible. Also, we cannot write the structure of a compound like this. Take another example. C double bond C, bond H, bond H, bond H. Look at that. Here hydrogen maintain monocovalency. This hydrogen also maintain monocovalency. This carbon maintain Tetra covalency. This carbon maintain also Tetra covalency. This hydrogen also maintain monocovalency. This hydrogen also maintain monocovalency. That means all the elements obey their fixed covalency. So this is an possible organic compound. Similarly, take another example: C bond H, bond H, bond C, bond H, bond H, bond H, bond H. Look at that. In this case, all the atoms obey their fixed covalency. So this is a possible organic compound. By the help of this fixed covalency, you can able to draw different types of organic compounds. You can also use the element like nitrogen, oxygen and halogen in the formation of the organic compound, but remember it is bound to maintain their fixed covalency. Remember an important compound: when you want to write a structure of organic compound, then it is bound to give the bond in proper manner, otherwise the structure of organic compound will be wrong. Suppose think about this organic compound, give a covalent bond like this. That means see, this clearly indicates that the covalent bond joined to this carbon and this hydrogen atom. If we will give the covalent bond here, then it clearly do not indicate that whether the covalent bond attached to carbon or hydrogen atom. So give the covalent bond in proper manner. As a result, we can able to identify that this covalent bond link between these two carbon atoms. Suppose take another example: CH3 bond C bond CH3 bond H bond CH3. Look at that here, covalent bond is present, which clearly indicate that this covalent bond attached to this carbon and this carbon. Don't write the structure like this. Look at that here, this covalent bond is in perfect manner, this covalent bond is also in perfect manner, this covalent bond is also in perfect manner, but look at that, this covalent bond is not present in perfect manner. This covalent bond do not clearly indicate that whether it attached to this carbon atom or this hydrogen atom. So it is bound to give the proper representation like this. If I will write a covalent bond here, then I can think that this covalent bond linked to this carbon and this carbon. So do not give the covalent bond like this. If you will give the covalent bond like this, then we cannot clearly indicate that whether this carbon atom attached to this carbon atom or this hydrogen atom. If I will give a covalent bond like this, then we can think that this covalent bond clearly linked to this carbon and this carbon atom. Next, I want to explain about the cartonation properties, or it is also called cell linking properties. What is the meaning of cartonation properties? The properties of forming covalent bonds within atom of the same element is called cartonation properties. Carbon having highest cartonation property, that's why the carbon atom can easily bonded with another carbon atom to form a large number of organic compounds. As a result, the number of organic compounds as compared to the other types of compound is more due to the high cartonation property of carbon among all the elements. Next, I want to explain about the classification of organic compound. There are different ways for the classification of organic compound. Generally, we follow two ways. Number one is classification of organic compound based on carbon skeleton. Another is a classification of organic compound based on function group. At first, I want to discuss about the classification of organic compound based upon carbon skeleton. Based upon carbon skeleton, organic compounds are classified into two types. One is acyclic or open chain or aliphatic organic compound. Another is cyclic or closed chain organic compound. At first, I want to discuss about the acyclic or open chain or aliphatic organic compound. The compound which have an open chain of carbon atom, that is a branched or straight chain, are called acyclic compound. Again I will repeat, the compound which have an open chain of carbon atom, that means maybe branched or maybe straight chain, are called acyclic organic compound. Acyclic organic compound are also classified into two types. One is straight chain organic compound, another is branched chain organic compound. Take an example, CH3, CH2, CH3. This is an organic compound. Take another example, CH3, CH2, CH2, CH3. Take another example, CH3 bond CH2, bond CH2, bond CH3. Next, take another example, CH3, CH3, CH2, CH3. Take another example. Look at that, all the compounds are said to be acyclic compound. Look at that, this is an acyclic organic compound, but it belongs to straight chain organic compound. This is also said to be straight chain organic compound. This is also said to be straight chain organic compound, but these two are said to be branched chain organic compound. This is also said to be branched chain organic compound. Remember an important point, straight chain organic compound means do not think that the organic compound must be written in straight line form like this. Look at that, this organic compound is not written in the straight line form, but it is also belongs to the straight chain organic compound. Then a question will arise, how can you identify whether an organic compound is branch chain organic compound or straight chain organic compound? Follow me, look at that. If I will think that this is the chain of carbon atoms, then this is your said to be a side chain of carbon atom. If I will think that this is your chain of carbon atom, then this is your said to be side chain. If I will think that this is your chain of carbon atom, then this is your said to be side chain. Chain means it have one starting point and another is your ending point. If I will think that this is your my starting carbon atom, and if I will think about that this is your my ending carbon atom, then it will form a carbon chain. But I cannot think that this is your starting or ending point simultaneously. When I will want to select this is my carbon chain. This may be considered as the side chain of this This is your branching of this main chain. Suppose a student think that this is the main chain, then this is your said to be branch of this chain. So this belongs to your branched organic compound. But look at that, if I think this is my starting carbon, then I proceed like this, then I will reach at this carbon atom, and finally I consider that this is my ending carbon atom. In this chain there is no branched chain, so this type of organic compound is said to be an straight chain organic compound. If I will think about this compound, look at that, this is your my starting carbon, then I proceed like this, then like this, and this is my ending carbon atom. Then these two parts are said to be the branched part. So this is said to be an branched organic compound. If a student wants to select the carbon chain like this, then these two parts are said to be branched part. If a student wants to select the organic compound having the main chain like this, then these two parts are said to be the branched part. Remember, if an organic compound having branching, then it is said to be branched organic compound. If an organic compound not having branching part, then it is said to be straight chain organic compound. Next, I want to explain about the cyclic organic compound. What is the cyclic organic compound? The organic compound which have closed chain or ring structure are called cyclic organic compound. Cyclic organic compound again classified into two types. One is your homocyclic, or it is also called carbocyclic organic compound. Second is your heterocyclic organic compound. At first I want to discuss about the homocyclic organic compound. The cyclic compound containing only carbon atom in the closed chain are called homocyclic compound. On the other hand, in heterocyclic compound there are different types of atoms are present in the closed chain. Let me explain with the example: CH2 bond CH2 bond CH2 bond CH2. Look at that, this is an organic compound. Suppose if I want to think that this is my starting carbon, then I proceed like this manner and finally reach at the same carbon atom. That means this carbon atom is said to be the starting and ending position of this ring. So this is a closed chain organic compound. This closed chain organic compound is said to be homocyclic organic compound because all the atoms present in this ring are carbon. This is said to be also carbocyclic compound because the atom present in the rings are carbon. Similarly, take another example: CH2 bond CH2 bond CH2 bond CH2 bond CH2 bond CH2. Look at that, this is also said to be closed chain organic compound. In this compound, the ring contains carbon atom. That means the ring contains same types of atom, that is a carbon. So this type of closed chain organic compound is said to be homocyclic organic compound. Like that, you can also think about this is the another examples of homocyclic organic compound. There are different types of example are possible for homocyclic organic compound. Take another example, look at that. This is said to be a closed cyclic organic compound. compound, and this is your ring present in this compound. Look at that. In this ring, all the atoms are not same type. That means your two types of atoms are present. One is your nitrogen, another is your carbon. That means the ring contains different types of atoms. So it is said to be a heterocyclic organic compound. Similarly, take another example. This is your said to be another example of heterocyclic compound. You can take also other examples of heterocyclic compound. Remember an important point, all the compounds obey the Tetra covalency of carbon atom. If a student wants to write your CH3, then this carbon atom do not satisfy the Tetra covalency. So this compound is said to be wrong. It is bound to give here two hydrogen atom because already one covalent bond attached to this carbon atom and other covalent bond attached to this carbon atom. For maintaining the Tetra covalency, it is bound to give two hydrogen atoms. As a result, two extra covalent bond will be formed. Totally, there are four covalent bonds are formed by this carbon atom. That means this carbon atom attain the Tetra covalency property. Look at that, all the atoms obey the corresponding covalency. You cannot write like this. If I will write like this, then the Tetra covalency of carbon atom is not satisfied by this carbon atom. Here only three covalent bond is present. One is this, another is this, and the third covalent bond is attached to the hydrogen atom, which is shortly written like this CH. So I cannot write like this. It is bound to write like this: CH2 bond CH2 bond CH2 bond CH2. These are the examples of cyclic compounds. The cyclic compounds are classified into two types. One is your homocyclic, another is your heterocyclic compound. What is homocyclic compound? The cyclic compound contain only carbon atom in the closed chain are called homocyclic compound. On the other hand, in case of heterocyclic compound, the cyclic compound contain different types of atom in the closed chain are called heterocyclic compound. Remember, again the homocyclic compound is classified into two types. One is your allycyclic, another is your aromatic. Allycyclic compounds are the compounds which having many properties similar to those of the aliphatic organic compound. That means such type of compounds have some similar property with the aliphatic compound, that is your open chain organic compound. These are the examples of allycyclic organic compounds. In next chapter, I will discuss clearly about the aromatic compounds. Finally, I can represent the classification of organic compound like this. This is the classification of organic compound based upon the carbon skeleton. I will teach you this part in next chapter. Next, I want to explain about the classification of organic compound basing upon functional group. Depending upon the functional group, the organic compounds are classified into different types, such as number one is your alcohol, aldehyde, ketone, carboxylic acid, etc. These are the different types of organic compounds which are classified depending upon the functional group. Next, I want to explain about the homologous series. What is homologous series? It is a series of similar constituted organic compounds having same functional group where two conjugative members differ in the molecular formula by methylene group, that is bond CH2 bond. Again I will repeat, it is a series of similar constituted organic compound having same functional group where two conjugative members differ in the molecular formula by methylene group. Let me explain with the example. Suppose take the compounds of alkane. First member of alkane is methane. Next is ethane. Next is propane. Look at that. If I will select two conjugative members of alkanes, suppose I want to think about methane, another is ethane. These two members are different by a methylene group. Similarly, if I will take these two conjugative members, then these two conjugative members are also different by methylene group. Next members, which is conjugative to propane, must be different by also methylene group. So these are the compounds which can able to form a homologue series. Similarly, take another example, alkene. In alkene, the first member is ethene, the second member is C3H6, the third member is C4H8. If I want to know about the fourth member of alkene, then I can add the methylene group with this molecular formula, then I can able to find out the fourth member of alkene. That means I can write here C5H10. Similarly, you can also able to find out the next member by adding the methylene group. The other examples are also found in alcohol, aldehyde, ketone, like this. Next, I want to explain about the characteristics of homologue series. First point, all the members of a series can be prepared by the same general methods. Second point, the physical properties of the members of a series shows a regular gradation with increase in molecular mass. Next point, the chemical properties of all the members are similar. These are the characteristics of homologue series. Next, I want to explain about the functional group. What is the meaning of functional group? It is an atom or group of atom of an organic compound which is responsible for the characteristics properties of that organic compound. That means by the help of functional group we can able to decide the characteristics property of an organic compound. There are different types of classes of organic compound. By knowing the organic compound, we can able to decide the characteristics property of an organic compound. For example, alcohol having functional group bond OH, aldehyde having functional group bond CHO, carboxylic acid having functional group bond COH. There are large number of functional groups are present. Next I want to explain about the representation of organic compounds. There are different types of representation of an organic compound. First is graphical formula. Second is structural formula. Third is condensed structural formula. Next is your molecular formula. Next is your bond line formula. Let me explain with the example. Suppose I want to think about the different representation of an organic compound, that is your propane. The graphical formula propane is drawn like this. This is the graphical representation of propane. For drawing such type of graphical representation, it is bound to show all the bonds present in between the atoms. Look at that, in this structure, all the bonds present in propane have clearly written. Next is your structural formula. The structural formula propane is written like this: CH3 bond CH2 bond CH3. For writing such type of representation, it is bound to show the bond present in between the carbon atoms. It is not necessary to show the bond present in between the carbon and hydrogen atom. Next representation is your condensed structural formula. I can write the condensed structural formula for propane like this: CH3 CH2 CH3. Look at that, in this type of representation, the bond present in between the carbon atom are not shown in this type of representation. Next is your molecular formula. The molecular formula of propane is C3H8. For writing such type of representation, it is bound to add all the atoms and give a formula like this. Next is your bond line formula. The bond line formula for propane is drawn like this. You can also draw like this. But remember, one line shows two carbon atom. Here one carbon atom, here also one carbon atom, here also one carbon atom is present. Here also one carbon atom, here also one carbon atom, here also one carbon atom is present. As your choice, you can draw the bond line structure like this. But remember one important point: one line indicate two carbon atom. Look at that, this line indicate two carbon atom. One carbon atom present here, another carbon atom present here. Similarly, this line also indicate two carbon atom. One, another is your two. That means in this structure there are three carbon atoms are present. 1, 2, 3. These are the various types of representation of an organic compounds. For writing the graphical formula, it is bound to show all the bonds present in between the atoms. For structural formula, it is bound to show the bond present in between the carbon atoms only. Do not show all the bonds for such type of representation. In condensed structural formula, it is not necessary to show any types of bond. In molecular formula, you can aggregate all the atoms and give a short formula. In bond line formula, generally we use some lines by which we can able to show the representation of an organic compound. But remember, here one line indicates two carbon atoms. This is all about for this class. Thank you. Have a nice day.